Hey everyone. So before we get rolling, does anyone have any questions from last week or running the Slurm scripts?
So, hey Jordan.
Yeah.
Whenever I ran it, it said that there was a QoS error. That's what it said. So what did it say exactly? And so I just couldn't do anything past that.
Okay.
It's the same. Helen posted on the command line. It was the same thing. So I tried
In
to run
the
the batch, and it said batch job submission. Yeah, the command line chat.
I see. Sorry, I haven't had Slack open today. Okay. And you're on Notch Peak, and you have Notch Peak specified at the top of the Slurm script?
Yeah.
Okay. Okay, I will look into that a little bit more and see what's going on. Yeah, sorry, I missed a couple messages on here today.
I'm working with Windows, so I don't know if through Putty, but I don't know if that might be something.
I don't think that would. So once you're in the supercomputer, I think this is going to be a supercomputer issue. And I think I've seen. Okay. I will take a look at this after class and figure that out.
Okay. It's just everything online that we could find just said basically access permissions to the supercomputer. So.
Okay. Yeah, if I can't figure something out quick, we can talk to CHPC and see if there's something that. I mean, I think you should have access to just run, but it may be an issue where Notch Peak works on a. Oh, okay. I think I know what it is. So with Notch Peak, this operates on an allocation basis. So basically, a lab can apply for a certain number of computing hours per quarter.
Right.
But you can also run a job on Notch Peak in the free cycle mode. So that's just whenever there's open space, your job is submitted without allocated hours. So normally how you do that. So there's two options. Let me, this will be faster, just, come on. Okay. So two options here. So I think the way to access that free cycle would be to run Notch Peak -free cycle. But there is the possibility that someone preempts your job if you don't have allocation hours. And so they could stop your job midway. So probably what I would suggest is submitting it to Kings Peak. And so that whole cluster, I believe, is running without any allocation. So it's just when your job has space, it runs it, and you're not going to have to worry about it getting booted off by someone else.
Okay, so instead of Notch Peak, just put Kings Peak.
Yeah, and you'll have to log in. So instead of logging in through Notch Peak, you would want to log in as SSH, your UID at Kings Peak.
Okay.
So that's just two differences there. And then you shouldn't get that QoS error. If you do, then it's something else going on that we need to figure out.
Okay.
So.
Okay.
Any other questions? see that there's one that I didn't answer about unzipping a file. Yeah, I will have to. So an issue with unzipping the SRA toolkit file. And it sounds like the file cannot be found. Was that command copied from the slide, or is it I don't know if Zaylee, was that
it is from the slide.
Okay, it could be a formatting issue if you copy and paste from the slide. And so I might just try retyping the tar-zxvf and then the SRA toolkit file name within your directory. Yeah, for whatever reason, sometimes the PowerPoint formatting doesn't transfer well with copy and pasting to the command line. And so that would be my assumption there.
Okay, I can try that. Thank you.
Cool. Okay, well, if anyone has any other issues with running those scripts and getting the alignment script to run, let me know. And again, if it doesn't work out the first time, that's fine. It's going to be a process of troubleshooting. And that's one of the reasons why we do this early in the class, is so that, like, if you don't get this working immediately, that's not a big deal. If you just want to keep on working away at it in the next week or two, that's fine. I think what we're going to be moving on to next is not necessarily dependent on what we've done before. And if you're not able to get a data set processed, I'll have some example data sets that you can use as like a mock analysis as we go through how to do some things in Python and how to do some things in R. So that if you do get a data set processed in the future, then you can take what you analyze this time and just kind of swap out file names and variables and how you approach that problem. Okay. So today we're going to start out with transferring files between the CHPC and your personal computer. And so this is really helpful if you want to do some kind of interactive analysis. So one example that we'll talk about is this interactive genome viewer. So you can look at read pileups of your BAM files. And then we'll start talking about a brief introduction to like Python programming and what are the different data types that you'll be dealing with. How do you make a function? How do you call external libraries to use other tools that other people have already developed? And I think, is Ian here? Yeah, Ian's here. So Ian knows how to do the copying files between Windows and the supercomputer. So if you're working on Windows, he'll explain that. It may be very similar to what we're going to do. But so whenever you want to copy files from the supercomputer to your own personal computer or vice versa, you're going to be doing that not on the supercomputer, but within your own computing environment. So I would navigate to my desktop. And this is where I'm going to be handling all the copying. And Ian, if you could just jump in, is this the same for Windows, or is there?
Yeah, I found it was exactly the same for the command lines, and I tested it both ways. I wasn't using PuTTY at all, though, so it was just a straight Windows command line to Linux and then back and forth.
Yeah, I think actually with PuTTY, you won't be able to do this, since I don't know if you can access your personal computer environment through PuTTY. But I think it's just the CMD app. Is that correct, Ian?
Yeah. So from Windows, it's you search CMD and then right click and run as administrator to avoid a lot of pitfalls. If you don't do that, it'll security stop you on.
Cool. And then with navigating to your desktop, is there anything other than just running, like how do you get to that path?
It's still CD in Windows, but when you want to see what's in the path, instead of ls, it's dir.
Okay. So if you're working with Windows and having issues navigating, just let Ian or I know and we can work through that. Ian will be the Windows expert for that. So I think the biggest thing is so the listing the files as dir, but then the other difference is going to be the absolute directory. I think, and Ian, you can again correct me if I'm wrong, but I think instead of doing like cd the / desktop. Okay, so Laura's commenting that with PuTTY you can set up FileZilla to move files. And so that may actually be more straightforward where you don't have to be using command line. I'm not exactly sure. So regardless, I'm going to show you how it's done on terminal in a Mac or Linux environment. And if you're running into issues with finding the path or anything like that, just let us know and we can work through that. But when you're copying files, it's very similar to just using the regular copy command, except for this is going to be SCP. So this is that secure copy. So it's using that SSH connection to run the copy command. And so if you were going to copy a file from the supercomputer, so I'll go here and say I wanted to copy, I think I had that. Let's see if yeah, it's deleted. So say I wanted to copy this FASTQ file here. So my process for doing this is I would run the pwd command to find the full path here. This will be helpful for when you're copying. So I would go to my desktop or wherever I want to copy the file, and I would say scp u my UID at we can use Notchpeak, or since it sounds like people want to be using Kingspeak, we'll do kingspeak.chpc.utah.edu. So that opens up that connection to the supercomputer. And then we need to, within the supercomputer, specify the path. So you'll separate this SSH URL with a colon. And then after that, you'll add the full path. You'll add the full path to the location of your file. And then in this case, I want to copy this file, so I will add that. And then you just do space, period. Sorry, I'm getting notifications again. Okay. And then this would, oh, sorry, I accidentally typed SCP twice. Okay. So then this will ask you for your password. You enter your password, and it'll open that connection to start the file transfer process. So the inverse of this is, say you want to move a file from your desktop to the supercomputer. It's very similar. You just reverse the direction, just like you would be doing with a normal copy command. But again, all this has to happen within your desktop environment or your personal computer environment. So I would just say SCP, I will copy this file. So I specify the file name as the first argument, and then the second argument is again my login at Kingspeak, and then that colon with the full path, except for here, I'm not going to give it a file name. I'm just going to give it the directory I want to move it to. But if I wanted to change that file name as it was copied, I could just say test.json there, and then that would run the file transfer between my computer and the supercomputer. So this is helpful if you ran, or if you wrote a script on your personal computer and wanted to move it to the supercomputer to run, then you can do that using this method. Okay, so are there any questions with how that works? Okay. So let me first find a quick file that sorry, my access to terminal is lagging for some reason today. Okay, so let's say I wanted to look at the read pileups of one of these BAM files on my personal computer. So and this may actually run into an issue where these aren't sorted, but we can try real quick. So the first step that if you wanted to do these on IGV would be to index one of these files. And so I think that, oh, sorry, samtools index. Okay. So like we talked about before, the first step to indexing one of these files is to sort that file. So I could specify this test sort BAM file as my output, and then the input is that. That was really fast. Okay, what is going on? Okay, there we go. So we have the test sorted file, and that's actually not going to work because these are all broken files. Okay, I'm gonna have to, unfortunately, I should have prepped one of these files beforehand to view, but we can just kind of broadly go over what this is doing. So when you have your sorted BAM file that's indexed, you would copy that to your desktop and then download this package here. And this will run on any operating system. But basically then you can open up IGV on your computer and say you downloaded your, where's that window? Okay. Still loading something. So say you downloaded the BAM file along with that BAM files index to your desktop, then you can just drag and drop just the BAM file into this window, and then say, well, we'll look at MPC1. So then it would display your BAM file below it with the read pileups here. So then I could zoom into one of the exons and see side by side, maybe there's higher coverage on this one exon than on another exon. And then you can also load in multiple BAM files at once. So if you wanted to compare read pileup between a wild type and an experimental sample, you'd be able to do that here. Okay, so let's talk about the next step of, say you have your process files, and now you want to do some deeper analysis into those files. And maybe there's something that you want to do, or some post-processing step that you want to do that's not readily accessible in a pre-existing command line tool. So that's when knowing another programming language such as Python or R comes in handy. So I want to start with going over Python. And I like to view this one as more of a kind of all-purpose day-to-day programming language where you can easily build tools, where there's a lot of basic utilities easily available. And it's very, I guess, easy to code in Python because it's very similar to just day-to-day talking. And then in contrast, R is very famous in bioinformatics for housing a lot of statistical packages. So say you had a read counts table from your sequencing data, there would be a lot of tools where you can import that data table into an R package and quickly run some kind of analysis on that data set. But a lot of the concepts between Python and R are going to be the same, like writing functions or accessing external libraries or dealing with different data types. So with Python, there's two ways to access Python and write Python code. So the first one, which I'll be this week using to demonstrate different aspects of the basics of Python, is using this interactive interpreter. So if I was on the supercomputer, Python's going to be loaded onto everyone's account, and you can just run Python, and that will open this interactive access point for Python. And so anything after these three caret symbols is going to be interpreted as a command to be executed. The alternative to this, so if you want to exit out of Python, you would run exit with parentheses, and that would return you to your shell. But if you wanted to, say you wrote a Python script, so a Python script is just a file name followed by py. And so I can just write this in Vim, or you could write it in a text editor that you then transfer to a supercomputer or run on your own computer. So say I wanted to print hello world, and that was my script. So with that, you don't have those carets. You just start a command on a new line, and then I can just run Python with the script name, and then that will execute the Python code afterwards. So I'm going to go back into the interactive editor. And so let's start by talking about the different data types that you'll be dealing with within Python. So in the command line, you're mostly focused on strings, which were used to provide a tool with a file name or an argument. And you can do a lot of different data type manipulation in the shell environment that we didn't really go over. But I think this will become more important with Python when you're building your own program and dealing with different data types, or if you're performing some kind of modification to a data table, and you'll need to be aware of the data type and the different considerations for that. So the first data type that we'll talk about is an integer. So this is just a whole number. So if I wanted to set a variable equal to 1 in Python, I would just write x equals 1. And then we can see that if we were to run type, So anytime we're going to run a function within Python, it's going to be the function name with parentheses and then that input. And so a function is just like with math, you have an input and an output. And so the input for this type function is a variable, so x, and then the output is going to display that variable's type. So if we were to run this, it tells us that the type for this variable 1 is an integer. And then we can also force variables or numbers to become integers. So if we were to say 1 equals int 1.1, and then if we were to display y, so that is going to force 1.1 to the integer rounded down, which is 1. And so this is important to be aware of, especially if you're mixing data types, because if you're mixing an integer and a number with a decimal point, it may force the sum of those numbers to be an integer, and then you lose precision in the output there. So it's important to be aware of what those different data types are doing and what can happen if you mix them. So then the expansion of an integer, a float. So this is anything with a decimal point. It represents a fractional value. And so this is where, if you're familiar with your operating system, so most computer operating systems will be 62-bit. And before that, a lot of operating systems were 32-bit. And so this is referring to basically the precision of values that operating system can handle and operate with. And so that's why with a 64-bit operating system, it can perform more complex tasks, is because it can perform more complex calculations because there's a higher level of precision with values that are stored in the system. And so a 32-bit system can access up to 32 memory addresses, and a 64-bit system can access to the 64 memory addresses. So that's maybe not as relevant to what you'll be doing, but basically with a 64-bit operating system, a floating point variable can hold up a basically twice the number of decimal places in a float. And just for your information, if you're interested in how this is working, so a bit is equal to a 0 or 1, and a byte is 8 bits. So that series of zeros and ones, 8 of those would store a value. So an example is this byte equals an exclamation mark, whereas this byte is a 0. And so if you are interested in looking into this more and how the computer is storing information and just the relevance of floats to all this, then you can look into some of these URLs to get more information about that. Okay. So I think one, also another consideration for when we move to R, and if you decide to stick with R. So in R, it does call a float something different. So it calls a float with 64 points of precision a double, and so it's just a double of a float. But in Python, it just refers to all of these as a float. So that's important if you want to force a number to become a float. So in Python, you would just say float float with the number, and then that forces that number to become a float. Whereas in R, it would be something more like as double. That's where that syntax would matter. So just another thing to be aware of if you're moving between languages. Okay. And so I kind of did this already where we can force a number to a different data type. So in this case, if we were to say int of x, then we get 1. So I think we don't need to review that anymore. We've already talked about checking the type of a number. And so functions like this, like checking the type of a number, can be important with some of these conditional statements that we will get into next class, where we want to say, maybe if this number is an integer, then we do this, whereas if it's a float, we need to do some rounding operation on it first, or so on. Okay. And then the last basic data type when you're programming is a string, which we've already kind of introduced in the previous classes. But in Python, if you're going to set a variable to a string, so say we want to say z equals hello. So whenever we specify a string, unlike in Bash where we could just say z equals hello, we need to specify the string with quotes. And so with Python, you can use either double quotes or you can use just single quotes. And then if we were to print z, then we have hello. If we were to check the type of z, we'll get a string. And just as another example, you can force a number to a string. So say you wanted to print out kind of an error message or some kind of update message in your program where you want to say like, this variable is set equal to the number. Then you could do something like print. So we have a string, this variable equals, and then you can either use a comma or a plus, and then we could just say string 1.23. And then we would get the combination of those two different data types for, in this case, some error reporting. Okay. And then if you wanted to store a series of variables or values in Python, so this is called a list or an array. And so in shell, we would call this something like L equals, and then we'd have 1, 2, 3, 4. So in Python, this is going to be denoted instead by brackets. And then we need to separate each value with a comma. So it'd be 1, 2, 3. So we'll call this one L1. And then if we wanted to make a list of strings, we would need to have each string with quotes around it, followed by a comma. So we can say this one's BC, and this one is D. And then we can also even combine different variable types, so it doesn't need to just be numbers or just be numbers or just be letters for strings. So you can say this one's 1, 2, and C. And so with arrays, you can also create multi-dimensional arrays. And so this is kind of a data table in a very simplified view. So you can see this is basically a list of lists here. So we have X and Y here were two lists of length 3. And so we have the list here, 1, comma, list 2, and both of those lists are contained within one set of brackets. But one important thing, so I'm gonna create this list here. So say we had made list 3 with a length of 4 and list 2 is a length of 3. If we were to try to combine these two lists, that is going to return an error due to unequal lengths. Oh, no. Oh, I guess it actually is okay with that. So I guess this is because this is because it's just a list of lists, it will allow for variable lengths of these sublists. But when you're accessing values from this can get kind of tricky where maybe you're expecting every list to have only 3 values, but then you have one in there with 4. That might throw off some operations that you're running. But say from this we wanted to access C from this multidimensional array. So the way we would do this is specify the list name, and then from the first list, which is these 2 elements. So if we wanted to access the second sublist, we would need to tell it to give us element 1. And so in Python, when you're counting, everything starts at 0. So if we say L4 index 1, we're going to get the second element because this first element is at index 0. So if we're then trying to get C from that, this is going to be element 2 from this second list because then it's 0, 1, 2. And so you can access different elements from lists using this indexing method. Okay. But again, since we're going to be talking about R later on, R is different where it starts indexing at 1. And so just be careful when you're grabbing something from a list by index, especially if you're switching between languages, because it may not carry over exactly. So you always kind of want to run some tests to make sure you're grabbing the correct elements when you're doing something like that. Okay, does anyone have any questions so far? Okay. So another option, somewhat similar to a list, is a set. And so, and there's 2 ways to define one of these in Python. So you can either use this set function operation on a list. And so here you see there's a list of numbers, but there is a double listing of 4. Another way you can do this is to surround this series of numbers by these curly brackets. So either of these will be identified as a set. But if you were to run this and view the output, as you saw in the slide there, you only get 1 instance of 4 listed here. And so the question is, why is this happening? So you can look at a similar data set, which is 2-dimensional here. So this is a dictionary, or in some languages, it's called a hash. So again, we can define this dictionary using the curly brackets. Okay, there we go. and say we wanted to add an element with a key. So a dictionary operates just like a book dictionary, where you have a series of keys or words and then their definitions or values. So here, if we wanted to say, there you go, first, so similar to indexing in a list, we're going to index by a name within a dictionary. So we could say the key first equals hello. This is really gone slow for some reason. And then we'll say the second one, I think I'm just gonna go back to the slides so I don't run into these lagging issues. So, and then B could be world. And then if you were to print this out, you're going to see a data structure like this. And then if you wanted to access one of those elements, you would access it by the named key that you gave it. But then if you were to, after you had set the key of A to hello, if you were then to set the key of A to goodbye, it's going to overwrite the value of the key A, like you see here. So the reason this is happening is the same for the reasoning behind why we're only getting one listing of 4 in this set. And that's because of how a set in a dictionary is storing this information in the computer's memory. So, and this is the reason why a dictionary is sometimes called a hash, is because basically what it's doing is it's taking that key value or that item value in the set, and it's converting that to a position in memory with a function. And so no matter how many times you enter a value as a key, it's always going to calculate that key to the same position in memory. And so if you're adding 4 twice to a set, it's going to say, oh, this is 4 equals position 1 in memory. There's already a value there, so don't need to do anything. But I think some of the day-to-day applications of these data structures, especially when we get into a genomics context, is say you wanted to just find a list of the unique elements within a list, then you can just convert that list to a set, and then you'll only have the unique elements in that list. And for a dictionary, if you wanted to, and this is an example that we'll work on next week, so say we had a data frame with a bunch of gene IDs as row values instead of gene names, and we wanted to convert the gene IDs to gene names, then we could create a conversion dictionary where the key in the dictionary is the ID and the value is the gene name. And then we can quickly substitute the gene IDs for the gene names within that data table. Okay. And then I guess from a, I guess you could call it a practical standpoint, knowing the differences between a list and a dictionary or a set and when you can use them can be important when you get to performance too. Because with, say you were going to search, so say you had a list of genes versus a set of genes, and you wanted to know if a gene that you're looking at in a data frame is found within that set or the list. So if you wanted to know whether or not that gene was in the list, the computer is going to have to search position by position through that list to figure out whether or not that item is in the list. So it could be really quick if that item is in position 1 in the list, but if it's in position 10,000, it's going to increase the compute time. Whereas if that list is instead a set, then it only needs to say, okay, is this gene in the set? Convert that that value to the position in memory and see if that position in memory is filled. And then it returns whether or not that was true. And so looking up values within a dictionary or set is a lot faster because of that. And so, especially if you're working with big data sets, this is going to matter, where if you can use a set or a dictionary, that could make an operation run in seconds versus minutes or hours, which we just talked about here. And so this is kind of a everyday example of how to think about this. Is, say you wanted to find Sal's office, but you didn't know his office number. You'd have to search every office in the building until you found it. Whereas if you already knew his office number, then you can know on what floor that office number is and how far down the hallway that office is. That's the difference of kind of speed walking through the whole office versus knowing exactly where to go. And so when you are running these operations, all these different data types and manipulating data, especially when you get to performing similar operations on different variables or different data frames over and over, that's when functions come into handy, where you can specify a known formatted input and specify known formatted output, so that anytime you want to perform an operation, you just have to basically write that once, and then you can provide different inputs or different outputs. And so that's where you can see before, where we're using this int, so to convert a variable to an integer, we can use various different values as inputs, and it will be able to quickly process that input value to an integer number, and we don't have to write out that whole operation by hand every time. And so we're going to be using this, especially when we, like I said, use that test case where we're converting gene IDs to gene names, where we may want to use this function over and over again. So we write this operation into a function, so that maybe we just have to provide a data frame that we want to convert, and then it'll just, the function will provide that converted data frame output. So these are a collection of these functions is what is referred to as a library or a package. And so there are a lot of libraries that are available within Python already, so they're just installed with Python. So an example of this is if you want to use Python and interact with the Bash environment, you can import the library called OS. And so that's one of those predefined Python libraries that are available. And this will have a collection of different functions that you can use. Whereas if we want to use an external package, so a very useful package for data frame manipulation is called pandas. So we could download one of these files using Conda, or one of these packages using Conda. So I think pandas is probably found on that SourceForge channel, but if you have those channels set, this should work just fine. And then once you've installed the package, which I think I've already done on this environment, then in Python you can run import pandas, which I guess I haven't installed it in this environment. But then the hundreds of functions available within the pandas package will be accessible to you. So I showed you how to do that here. And if you were going to say import one of these functions to the, I think we had made that hello script right here. So normally you want to import these functions at the beginning of your script. Since the script is running sequentially, it needs to have those libraries imported before you're going to use them anywhere. So if I wanted to use the OS script, I could run import OS there, and then down the line I can run some of the let's see, some of the functions within the OS package below within the script. Okay. So that's all I have for content today. So to practice some of these concepts, if I don't know if anyone's done this already, but transfer some of the BAM files once you have those downloaded or once you have those processed to your personal computer and download that IGV package. And then look at one of those samples within IGV and try to find a gene where you can find differential expression of different isoforms. And then to review some of those concepts of Python and these different variable types, create a dictionary of classroom students and their test scores, create an array or a list of students' names, and include some names that were not originally in this dictionary, and then access each student in the array and figure out if that student was in the dictionary, and if they were, print out student so-and-so, print their name, got a score, whatever that score was on their test. And so you can either run this in the interactive mode in Python and then just maybe save the commands that you ran to a text file, or you can write a Python script to run these. And then also, just as one final announcement, I haven't posted the homework answers from last week. I'm hoping to get that posted either today or tomorrow so that you'll have those to reference. So does anyone have any questions for what we've talked about or any other questions in general? Okay. Well, if there are no questions, I will see you all on Wednesday. Oh, okay, there's a question. Can you import an array from an Excel sheet? So yes, you can import an array from an Excel sheet. Well, so not directly from an Excel sheet, sorry. I think generally you're going to want to use a plain text formatted spreadsheet. So let me just open an Excel spreadsheet real quick. So I guess we can say we'll have score, student 1, student 2, student 3, and we'll give them their scores. So if this were an Excel spreadsheet, I would want to, when I save this, I go to save as, so maybe we'll call this scores. Instead of an Excel formatted spreadsheet, you'd want to go down to either a tab delimited file, or you can also use a comma separated file. So generally I stick with the tab delimited file. So I'll save that to just my desktop in this case. And then I'm going to return to my desktop. And we're going to go over this in a little more detail in some of the future lessons. But say I was in Python, I would import that pandas library. And then you can just use the function pandas dot. So we want to use the read CSV function within that pandas library. And then I can just specify my desktop scores.txt. And then in this case, it wants to know, are these values separated by commas or tabs? And then I think we need the row index. So this is just to say use the first column as the row names. Okay. Yeah, okay. So this is something I've done hundreds of times. Like I was saying, I have forgotten the an example of how do I use an argument. So I'm gonna just Google search the documentation, search through here to find out how I use that. Okay, so it's index underscore call. This is going to say use column 0 as the index there. So as you can see, it prints out that data frame in a data frame format. We can save this data frame as a variable, so we can look at that. And then we'll also go over in the future how do you, so maybe you import a data frame and you run some kind of operation or manipulation on it and you want to output the manipulated data frame, then you'll be able to use another function within pandas to do that. But we'll get into more detail about using data frames within Python and R as we go along. Well, I'll just hang out here until people leave. And if you have any other questions, let me know before you take off.